Hello everybody, in this video we are going to be dealing with sketching a linear function. Now when sketching functions in general, there should be a bunch of steps to take into consideration. Alrighty, so here's our steps, right? It kind of is only two when it comes to preparing, but domain and range is important still. So we have the following. Step 1, we need to find the x and y intercepts. And step 2, then we can just sketch it. Go for it. That's for linear functions, of course. And then step 3, we need to obviously show what is the domain and range for that function. Okay, cool, we're ready. Let's get to the first example. Okay, so here's our first example, right? We need to sketch the function of f of x equals to 2x minus 3. So obviously for this one, the first step is to find the intercepts. And with intercepts, we need to understand what do we mean by intercepts. Now, think about it this way, right? If we have a Cartesian plane, I'm going to just draw like a small one here. The y-intercept is any point that touches the y-axis, okay? So we should know that if we are dealing with the y-intercept, we know that the x value should be 0, and then we just have the y value, okay? So whatever y value. The reason why x is equal to 0, because notice that this is the y-axis and this is the x-axis, and it is in line with the x equals to 0 point, okay? So notice that x is equal to 0 and it's in line with that point, okay? And if we're looking at the x-intercept, we're going to talk about the value where x exists but y is equal to 0, okay? Because it's in line with the point where y is equal to 0. Okay, cool, because we know that this is the origin, right? So therefore both those points are 0, and when they're in line with each other, you'll note it is that way. So notice that if we want to find the y-intercept, so if we want to find this value, our input x needs to be 0 in order for us to find the y-intercept. And in order to find the x-intercept, to find our x value over there on the x-axis, we need to let y be 0. Okay, so that we can fulfill this intercept logic. So therefore, if we want to find our x-intercept, okay, we are going to let y be equal to 0. So that what happens here is, in our equation, notice that f of x is actually represented by our y-axis, meaning this should be our y value. So therefore, it's going to be 0 is equal to 2x minus 3, okay? And then we just solve for x from here. So 2x is equal to 3, and then x is just equal to 3 over 2. Okay, cool. Now that we found our x-intercept, we need to find our y-intercept. Okay, and our y-intercept is where we let x be equal to 0, right? Because of this part over here. Because our x is 0 and our y is 0 for the x-intercept. But anyway, here, if we let x equal to 0, then it's just going to be f of 0, which is just going to be equal to 2x, or not 2x, it's going to be 2 times 0 minus 3, where f of 0, which is basically the y value at x equals to 0, we are going to have negative 3, okay? So notice that the x-intercept over here is just going to be 3 over 2 and 0, because remember that we let y be equal to 0 to find 3 over 2. And then here, for the y-intercept, we let x equal to 0 so that we can get negative 3 as our output, okay? So that's basically also the whole idea of functions, is when we input something, we should get some output. And when we input 0 into one of them, we get an intercept, essentially, if you think about it. Okay, cool. So I didn't really mention it, but remember that in the equation, we know that this value here, negative 3, should be our c value, which is our y-intercept. So you don't have to use this logic for finding the y-intercept. However, when it comes to maybe things such as the parabola within your grade 11 year, or the hyperbola, or whatever other function within your grade 11 year, usually it is important to understand this logic. Obviously, using just -3, it makes it easier for you. So I would recommend only using this once you understand this part. Okay. Because when you understand this, then you should be more comfortable doing this. However, this saves time, obviously. Just saying that -3 is indeed the y-intercept. Okay, and obviously it'll always be the y-intercept because when you multiply by 0 by the gradient, then you're just left with the line, which is -3. Okay, cool. And now we can get to our second step, which is sketching. Cool, this is exciting. So we need to sketch. And then here we are going to have our Cartesian plane. And then all we're going to do is just draw the points that we have, but first indicate this is the y-axis and this is the x-axis. And then notice that our intercept is 3/2 and 0, so obviously it'll be somewhere around here maybe. The x-intercept, and then the y-intercept will be somewhere maybe here, where we can call this point 0 and 3. We can call this point 3/2 and 0. And notice, because it's a line equation, there is no other change in terms of the shape. It'll just be a straight line, so that's why you only need 2 points. And then obviously having the x and y intercepts is already more than enough that you need in order to draw your line. So there we go. There is your function of f. And now we just need to understand what is the domain and range. Okay, cool. So domain and range, let me write this down for you. Okay, so the domain is essentially going to be the x values that exist on our function, right? It is the restriction for our x values. And then the range is now the same thing, however it works for y values. It's the restriction for our y values, okay? So what do you notice here? When we look from left to right on this function, don't be fooled by the gap that we have here. Obviously, it's not drawn to scale. Notice that this arrow indicates that it's continuing on forever, okay? So there's no stop. It just goes on all the way to -infinity, okay? And then this arrow here means it's going all the way up and to the right, infinitely, so to positive infinity, right? Meaning, if we look at the domain, we are looking on the x, according to the x-axis, obviously. We're looking horizontally. So if I were to just take my mouse here and go from left to right, notice there is no point where the function doesn't exist. Obviously, we can't see the rest of the function here because this is an arrow here, okay? But it does go all the way to -infinity, meaning it goes, the x values can actually go from -infinity all the way to positive infinity. So which means this indicates that x is the element of, you could either say -infinity to positive infinity, or you could actually say x is the element of real numbers, right? Because real numbers is actually the exact same as this. This is also indicating -infinity to positive infinity. Those are all real numbers, okay? Obviously excluding -infinity and positive infinity, because those aren't actually numbers. Those are just endless. There's no end to these. They're just either very big or very small. In terms of range, notice that is just going to be the vertical relation, meaning we notice it does travel all the way from -infinity and goes up all the way to positive infinity. So it's exactly the same. However, instead of x, it's going to be y. So y is the element of the range from -infinity to positive infinity, or you could say x is the element, not x, y is the element of real numbers. Okay, so that is the whole idea of domain and range. So that is also how you sketch that function. And then it will basically be exactly the same overall. The other type of question you may also get is maybe like an intersection question, but that wouldn't be covered in this video because we only depending on the sketching of one function here. You could get a question which gives you the intercept and the gradient, and then you just need to determine the points, which obviously if they do give you the intercept and the gradient, then, well, I mean, from there you can just find the equation as is, then you can work from here again. They could also give you a question where they maybe they give you the gradient, however, they don't give you the y-intercept, but they give you a random point on the graph. And you actually have to use that logic that I've used in the previous video with determining the equation of a straight line to understand where do you get the extra points. And then you can actually find the y-intercept. And then you can now start with these steps. So the only times you can start with these steps is when you determine the actual equation, okay? And then you can continue with these steps, sketch your graph, and then find the domain and range, and then you should be settled for the whole question.